Greetings everyone, this is Mr. Mull. Today I'm doing a podcast to help you with some of the questions on the More Wavework homework. So I want to get started here right today talking about some of the problems that you might run into with units for some of the questions like number 5 and 6. So this is a question that I found, and in this question it says the brilliant red colors seen in fireworks are due to the emission of light with wavelengths around 650 nanometers when strontium salts such as strontium nitrate and strontium carbonate are heated. This is something that we could do. So we see these red colors in the fireworks, and it's asking me to calculate the frequency of that red light if it has a wavelength of 6.50 times 10 to the second nanometers, 650 nanometers. So what I want to do first off is I want to write down some things that I know. First off, I know that this is light. Okay, so when we're talking about light, we know all light has a certain speed. Speed of light, 3.00 times 10 to the 10th centimeters per second. Okay, so this is our speed of light. The question asks me to calculate the frequency. Don't know what that is. I'm going to put a little question mark. And it says that the wavelength is 6.5 times 10 to the second nanometers. So I'm going to write that down. Wavelength equals 6.50 times 10 to the second nanometers. So I need to find frequency. So looking at my equations for waves, I'm going to find out and remember that the speed of light is equal to the frequency times the wavelength. If I rearrange that, get frequency by itself, divide both sides by wavelength. Okay, they go away. Oh, that one doesn't cancel. I'm going to get speed of light divided by the wavelength is equal to frequency. So what I'm going to do is I'm going to plug this in and use what I have. Frequency equals, and if I write my speed of light 3.00 times 10 to the 10th centimeters per second, divide that by my wavelength in the units written, 6.50 times 10 to the second nanometers. I want to get a unit of frequency, hertz. So I need basically nothing over a second. Well, I have the per second on the top, but can I cancel centimeters with nanometers? Or do I have to convert those units to the same unit so we can cancel them? Well, the answer is we do have to convert them. So we're going to have to do a little conversion problem from our first unit, and we need to turn our nanometers into centimeters so we can do this conversion. So I'm going to go ahead and do this kind of on the sideline here. We need to convert 6.50 times 10 to the second nanometers into, we need to turn that into centimeters. So what I'm going to do is I'm going to do a conversion from nano to centimeters. Nano is 10 to the minus 9th. You have that on your conversion chart. Centi is 10 to the minus 2. So if I want to find a converter to go between these two units, I take my first number, negative 9, subtract my second number, minus 2, and I'm going to get negative 7. What this means is I can make a new conversion factor. In 1 nanometer, take that first unit, is equal to 1 times 10 to the, take that power of 10, negative 7, take your second unit, centimeters. So what I'm going to do now is I'm going to do a conversion problem to get rid of those units. So I'm going to go ahead and we can do this any way we want just to get rid of those units. So I'm going to multiply this whole value that I have for my frequency just to get my units right. I'm going to go ahead and put 1 times 10 to the negative 7 centimeters on the bottom and 1 nanometer on top. Nanometers cancel. I'm going to have to divide this whole product of these two numbers divided by each other and divide them again by 1.0 times 10 to the negative 7th. So now once I've done that, I'm able to get the right units that I need. Okay, and we're going to get a frequency that's close to the frequency of red light. Okay, so we can go ahead and punch this in and get an answer. We could do that. The other way you could do this is instead of doing this conversion bubble, you could just take your nanometers directly, convert them into centimeters, and then plug it back into your equation. Okay, plug it back in to your equation there. Okay, so you could do either one of those. So you can go ahead and punch that in and see what you get. And there's one other thing I'd like to bring your attention to as you're working through this worksheet. and that is the point of some of these problems. The point of some of these problems is that we need to find the energy change. Because if we can find that change in energy, okay, delta E, then we can find a lot of stuff. You know, whether I'm looking at an electron jumping from, let's say, the first energy level to the fourth energy level, well, electrons have certain energies at that energy level. Okay, remember that we can find that energy, the kinetic energy is going to be equal to the ionization energy. Remember, that's the energy needed to remove an electron. That amount of energy divided by n squared, which is just the energy level squared. So we can find that little energy, okay, you know, E1, E2, and we can find the change in energy. When we find that change in energy, we can use that to calculate frequency, and maybe use our E equals HF. Once I found the frequency, I could find the wavelength of that light, okay, using that speed of light equation. And once we know these two things, well, if I know the frequency, I know the wavelength, I can know what type of light we're talking about, okay? So I can know what kind of type of electromagnetic radiation. You know, is it visible light, is it radio waves, is it X-rays? You know, what kind of light is associated with that energy and those frequencies and wavelengths. That's kind of the whole point of this thing. So use these ideas to help you solve that worksheet. Watch your units. Make sure that, you know, remember that kilojoules and joules are not going to cancel each other out. Okay, so you're going to have to convert kilojoules into joules. And remember that there are 1 times 10 to the third joules for every 1 kilojoule. That might be some helpful information. Alright, good luck, and I'll see you guys tomorrow. Bring any questions you have to class. Hope this was helpful.